Okay. As I was mentioning yesterday, this is one of the topic which is pretty interesting because this is how a lot of internal mathematical computation is done, and this is what makes it really fast. Okay, so let's understand what it is. Okay, let's understand what is broadcasting, how to do various things with it, and what are some big questions here. Okay, so this line is typically importing the library. Okay, and what you're doing here, you're creating two vectors, right? So what is a vector? Vector is like a unidirectional matrix, right? In this case, it is actually 1 cross 3 matrix, the A and B, right? Okay, so any row matrix means you have only one row, column matrix means you have only one column, right? So these A and B are vectors. So what is vector, right? The important thing to here to understand is almost everything in this universe can be represented in vector format, right? For example, if you have to create your vector representation, the vector might actually have your name, your age, your location, all the things converted into numbers and stored, right? So please understand that for machine learning you need to convert any form of data into some vector format. Okay, so here as you can see here you have A and B, two vectors, and these two vectors are of same size, right? As you can see, these two vectors are of same size. So if you do vector addition here, A plus B, okay, since these two vectors are of same size, it will be element by element addition that will happen in this case, right? 0 plus 5, 1 plus 5, 2 plus 5, element by element addition. Okay, this is the prerequisite for doing vector operations. It should be of same size and all. Now you see more contents here. Okay, like say example, if the arrays are of same size, like these vectors are of same size, element to element operation takes place. Okay. Now see the next element, A plus 5. What is A? Vector. What is 5? Scalar. Right? A vector and a scalar. So when you do is vector plus scalar addition, so a very interesting thing happens over here. 5 gets added to each of the element here. Did you notice this? 5 plus 0, 5 plus 1, 5 plus 2. Right? So how is this thing happening? What is this concept? This is what you call as broadcasting. Okay, so what it does is this scalar value 5 gets converted into a vector, right? And then the operation takes place. So you can understand. So this 5 value gets converted into array of 1, 3 of 5, 5, 5, and then the operation takes place. Right? This is implicitly happens, right? Okay, let's see more things. This concept of this is what was happening here, right? So you have a NP.
It won't happen with the list. It is whenever you declare with the NP array only it will happen, or
no, NP array. These are your Numpy operations. Won't happen otherwise. So you see here you have NP arrange and you have the 0, 1, and 2. Okay. So what is this? This is your array and a vector with this value 0, 1, and 2. And when you are trying to add a 5 here, what it does, you can see the shaded values over here. It actually creates a vector out of this. It repeats the content. You know the technical meaning of broadcasting, right? Broadcasting is repeating the information to everybody. So that is what it is doing here. It is actually repeating this 5 information to 3 times, right? And eventually this plus this operation which results into this, right? This is one level of broadcasting. Now we'll see a little complex stuff. For example, you see this, we have this matrix, right? Which has this data 1, 2, 3, 4, 5, 6. Right, it's a matrix, and what you're doing here, A plus 5, you're adding 5 to this matrix. So what is the dimension of this? 2 cross 3, right? So 5 needs to be converted into 2 cross 3. Right, what will happen? 5, 5, 5, 5, 5, 5. Right, then the operation will happen. So what is essentially you seeing that is happening here? From scalar value, it is actually converting that into vector of similar shape that will the other guy, and the operation is happening. Okay, say for example you have this guy.
So 5 also becomes 2 cross 3 of that. And it gets added.
See here what happens. You have NP ones, 3, 3. That means 3 cross 3 matrix of all value ones. Then you have NP arrange 3. Okay, NP arrange 3. So what you're doing here, you are actually generating an array of 0, 1, 2. You have to do this, add this plus this. What will you do? You'll repeat it, right? So what you're seeing, what is the understanding that is getting to your mind? If you if you can repeat something and make it of same size, then the operation can really happen, isn't it? Right? If you repeat something and the size becomes same as the actual other operand, the operation can really happen. Okay. So see this. Okay, well, I'll discuss more things, but see one more thing. So what do you see here? NP arrange 3. Arrange 3 means 0, 1, 2. And you're doing a reshape 3, 1. That means it will create 3 rows of 1 column. So data actually looks like this, 0, 1, 2. So this data, it is NP arrange 3. It is like this. If you are doing operation between them, it will actually add to 2 more rows. It will actually add 2 more columns. It will actually add 2 more rows. Eventually, it will be able to do the addition because the resultant is of same size. Right? Got a sense of it, right? What is happening? We'll see more things so that we can understand what is the.
I don't get the last one.
Last one, what is the shape of this? Like last one, this is the stuff, right? 3 cross 1. This is how it looks like, right? Then this other guy is this. B.
Yes.
B is this guy, right?
Yes.
When you do A plus B, you're still getting the value. Right? So how can you add this and this? Because both will undergo some change, isn't it? And then it will get into same shape. Then only it can do the operation. Okay? This observation leads us to 3 rules of broadcasting. Okay? First rule is rule 1. Very precise rules. If 2 arrays differ in the dimension, the shape of one with fewer dimension is paired with one with ones in the leading left hand side. What does it mean? Okay, 2 arrays have different number of dimensions. That means one array is 2D array, other array is 1D array. Okay. Then the array with fewer dimensions. That means in this case, M and A is here, right? A is the one which has fewer dimensions, lesser number of dimension. Okay. So what it will do? It will is paired with ones in the left hand side. So here what it will do? It will actually convert this into 1, 3. Okay, this is your 5 cross 3. M is 5 cross 3, right? And here if you do 1, 3, it means what is the vector? 1 in one row of 3 elements, right? Then you are able to replicate that stuff, isn't it? Then the operation can happen. Understood how this is? We are talking about the first data that we saw, right? So here it is 2-dimensional data. Here is 1-dimensional data. Now what you are doing here, you are trying to add one more dimension here, and you're repeating this. So just this is the important point here to note is whichever dimension is 1 dimension, you can repeat it. Right. Okay. So that is why if the number of dimensions are different, add 1 dimension in such a way that it repeats and it becomes the same data structure. Okay, we'll do some exercises also to make it very clear. What is the rule number 2? This is when you have 2 Numpy arrays with first rule, right? If 2 arrays are different in the dimension, shape of one with fewer dimension has in the left side, you're adding 1 more dimension to that. Okay. You don't have to remember these 3 rules actually. I'll tell you one shortcut is like derivative of this 3. Okay. So if the second rule is if the shape of 2 arrays does not match in any dimension, that means we have different dimension array. 5, 2, 2, 5, whatever. Okay, the array with shape equal to 1 in the dimension is stretched to match the other shape. This is some kind of derivative of the first one, isn't it? The shape does not match. With a dimension in which it is 1, you will increase it so that it matches the shape eventually. Third is if any dimension the sizes disagree, neither even the error is fixed. Okay, so how can you actually do vector addition? Okay, the thumb rule is as long as they are of same shape, if they are a different shape, one of them should be equal to 1. Okay, then only you will do vector operation. Let me show what I'm trying to say. Okay, I'll just write it here. Okay, so let me create X is equal to NP array (1,2,3). Okay, Q X dot shape. Okay, so here can you how will it happen? Of course, it allows you X plus Y, isn't it? Why? Because Y will Y, the dimensions are different. In the Y, it will add 1 in the prefix and it will repeat it. Right? So this is cool, not a problem as per our first rule. Problem starts happening when, can you tell me how to do this operation? Can you do this operation? The shapes are different. Okay, if you add 1 in the left hand side of this Y, will this operation be valid or not? Right, it is not possible. That is because if you add here 1, okay, the rule is the dimension should be same or one of them should be 1. That is a derivative rule. Understood, right? So here, this is different. You can of course add 1 before it, but this is different. Not possible. But we can make it possible, isn't it? If you can convert this X and Y into some shape. Okay, so what we can do is X dot reshape. Okay, 2, 3 is there, right? 2, right? Y dot reshape 1, 1, 4. Can we do operation between them? X1. Can you do operation between them? For two different matrix or vector, for the operation to happen, either the sizes should be same. If different, one of them should be 1. Does it fall in that rule? So will this work?
Yes.
Yeah. Understood, right? What's happening? Right? It is this method, this broadcasting comes very handy if you want to find distances between infinite vectors. What is distance between two vectors? X1 minus x2 plus y1 minus y2. You get this operation. So if you the last one, what you're doing here, you are actually manipulating this content. See, adding one shape do not require any addition of data, isn't it? Okay, so what is happening in this case is you are actually, because of this, either the shapes are same. In this case, nothing is same. Wherever they're different, one of them is 1. Yeah. Don't try to understand the dimension. It's 3 dimension because it is difficult to understand. Just imagine. Don't worry about it. But the thing is, you are able to do this operation because of rule. Okay, so you have some questions? Let's solve one problem. Okay, I'll give the data. Z is, say, U is equal to, okay, understood the rule, right? Just keep that rule in mind. Yeah, do some reshaping and all that so that you can do an operation between them. Are we finished?
We are done.
Done, huh? Okay. So what did you change the shape into?
First, in the U1, I did 3 comma 3 comma 1. Then after that, in the V dot reshape 1 comma 1 comma 4.
Any other solutions? Because there are a lot of correct solutions.
Actually, whatever you did in the previous one, the same on the previous.
Yeah, that's the context. So what you do here, okay, you basically have to make sure that you can add more dimensions. So you reshape. Just think 3 comma if you want to do this 1 comma, then this is fine. Plus v dot reshape 4 comma 1. Right. I mean, there are always a lot of ways to do this, as long as you can fit into that rule of either they should be same or if different, one of them should be 1. That's the thing they have to remember. That's it. No matter what dimension it is, you don't have to think about dimension. Okay, if you're
3 comma 3 comma 1 and 4 comma 1.
3 comma 3 comma 1 4. Oh no, there is a map. If you convert it into 3 comma 3 comma 1, you will not get one of them same, right? And 4 comma
4 1 1.
like this, right? So what will happen? The first one is 3 and 4, right? You cannot have this. Either they should be same or one of them should be 1.
The first one itself.
Everyone. So in this case it will complain that it is not same. So if I get into the earlier one, like here, see, either they are same, which is not in this case, or when they are different, one of them is 1. Okay, if you want to try, okay, give it one more shot. Can you do operation between them, this U and V? You have to create, do addition between them.
Still 1, 3, 3 is not happy. 1, 3, 3, and 4, 1, 1. Still there.
No, it will work. You are doing V shape and reshape. Make sure you're doing right in the correct way, it will work. Right? This is something that will work, right? Okay. Okay. So I think everybody got some understanding of broadcasting, right? We tried various steps. There are a lot of questions around it. Okay. In the assignments, try those out. It will give you a good understanding. Okay. Okay, a few things. Okay, the next thing is masking in Numpy. Okay, masking. So masking is very important because it lets you actually filter data and many such operations. Okay, so see how this is happening. So what is this Numpy random variant is doing? Right, NP random variant. It has data. It is generating data from 1 to 10, right, of 20 elements. And if you do this, what is it that it is returning? It is returning a Boolean array. Boolean array means array which consists of true and false. And whichever data is matching this condition, it is returning true, otherwise false. Right? This is a Boolean array. The important part here to note is, again, important part, if you pass a Boolean array as an argument to a array like this, you will get only the data which is matching to this. Right? This is how it is important here. Whenever you have the Boolean array, you can pass that to an array. It will return only the data for which the Boolean array contained true.
Index it will return the value.
Data. Value. Right. That's why we have A here. Right. Boolean array.
Can we get the index from this?
Which index is true? We can get that using NP where. Okay. Yeah, say you have this NP where. You see, we are getting the indexes at which this is true. So you can pass these indexes to A again. This is one way to get the data, and if you want to pass the Got it, right? Now let's see. Again, what are you doing? We are generating some random numbers. Okay, let's write this activity. And everybody understand what am I doing here? Okay, so what is happening over here is we are actually matching this condition, right? If this condition is true or this condition is true, it will return those indexes, and that we are getting it over here, right? So write the code now. You find all the numbers randomly generated, all the numbers which are multiple of both 5 and 7, or say 5 and 10.
Between 1 and 10.
No, you take a larger number in that case. Okay, between 1 to 1 million, 1,000, 10,000. Find all the numbers which are multiple of both 5 and 7. Okay, between number 1 to 1,000. Everybody executed that? All the numbers are divisible from 5 to.
What are the size?
Random. What is the size?
Size 100 data you want.
Random.
Random 100 numbers out of 1 to 1,000. So these are all the data which is divisible by 5 and 7 both. That's it, right?
What is the difference between before you kept the data in front?
If you don't keep the data before, you'll get the index number only.
Okay.
If you pass the index number to the data, you will get the contents of it.
Original data will not be changed. Original data will
No. You just return your filtered data. Fine, everybody? Okay.
You are getting data type as well.
You're unprepared.
And the output.
Somewhat, maybe you're telling us some latest release and all that sort of things. Okay, so now we are moving to the next topic. Okay, everybody's comfortable with things with Numpy, right? Got a sense of it. I mean, you'll basically deal with it. So, but understand, a few things that Numpy is basically meant for doing. It's a very low level library here. All the scikit-learn pandas actually use Numpy for all their utilities. The Numpy usage is not limited to whatever we have discussed here. Okay, but we will be using higher level libraries to do many things. It's like if you there are things like, I mean, if you see here, like there are few names I didn't take, like ufunc. Okay, yesterday we saw std, mean, all these are known as ufuncs, universal functions. Okay, universal functions. So again, having said that, when you use pandas, with the API that you see in pandas, you'll literally use internal numpy. Got it, right? So, but this much, pretty much numpy is good enough to unblock you from your future learnings, more or less. Okay, if you find something new, it should not be a difficult thing to comprehend that. Got it, right? So this much, whatever notebooks is there, you cover this much. I don't think 90%, 95% you will not need to refer any documentation. Okay, some exceptional thing might happen, which for that
You can go to the
assignments. That this is more than sufficient that you is required to unblock you for future learning. Okay, that's after that we get into pandas. Okay, so to complete all the assignments in Numpy, okay, whatever you see in the data sets, and okay, just finish all the things. In there, you're supposed to get few new things. 2-3 things I have mentioned over there, which intentionally is not spoken in the sessions. Precisely the reason is you should be comfortable in looking up in documentation. Okay, because as we proceed further, these libraries are definitely not limited to whatever we discuss in the classroom. It's much beyond it. The expertise that you should focus in is understanding the core concepts, dealing with the functions which helps you 85% of the time. Okay, and you should be comfortable looking for documentation, finding how to there is some new way around it, adding in those states. So you focus on these areas. Let's proceed further with pandas. As you can see, pandas is a high perform. Is that somebody's water or how much? Because here only.
yesterday.
I don't know from where. Okay, so yeah, pandas is talking about. So okay, it is a high performance open source library, very similar to your Excel sheets. Like you heard about Power BI from IBM, anybody? Cognos. Heard about it? So there are a lot of such
The business intelligence tools.
BI tools, right? These are all BI tools, pretty famous in the market, and there are a lot more of them. The one point is, it is paid. I think they are not free. Okay, what is Pandas doing here is free. It is easy. Okay, and there is an open source community which is helping to make it better. Got it, right? So if you know it, you can actually, without paying anybody any money, you can do data analysis, isn't it? That's the idea. Okay, what is Pandas? It is an open source, high performance library for doing data analysis. This is the replacement for Excel sheet. This is the replacement for Power BI. Like, what is the problem with Excel, Microsoft Excel and all that? You cannot deal with a lot of data, right? You cannot deal with a lot of data. A Power BI, it is little expensive, right? You might not own it. Okay, here it is kind of both of them.
It's kind of the replacement Tableau.
Tableau's replacement is, to certain extent in Matplotlib, Bokeh, that is the Tableau's informatical replacement. Okay, so and the other thing is it processes data with different formats. Okay, CSV, JSON, data from databases. Like you have data from databases, you can connect that using Pandas and write some queries around it. Okay. Then it allows you to do all the database operations like merge, join, slice, okay, subset. You can do pretty much all the operations that you can do with. Okay. Then it actually has utilities to handle missing data. Got it, right? If there is some data which is missing in the table Excel and data frame, so it provides utilities to actually how to handle it. That may involve removing it. That may involve replacing the missing values with some actual values. Okay, finding in a column if some data is missing, finding the mean of that column and replacing it over there. A lot of such utilities. Okay. Then you can use it for doing statistical analysis as well. Okay, this is the part where suppose you want to do some mathematical computation, statistical analysis. You can do like correlation, Pearson correlation, Poisson correlation, whatever mathematical things you want, you can do that using Pandas, which internally will use Numpy.
Pandas are the extension to Numpy.
Pandas are the libraries which is using Numpy.
Internally it imports Numpy.
Right. Got it, right? That is why I say, for doing a lot of these stuffs, you will be using Pandas directly. Not, it's because it's quite mature and have a lot of things. But understanding Numpy is important because you know how internal things works.
So usually we won't generally like we just do directly Pandas. We won't use Numpy much.
No. You have whatever operations I showed you, right? Suppose you have one column, you do some, sum of that, some normal operations, random number generation. You use Numpy. Whatever operations I showed you, right? Apart from broadcasting, you'll use all other things in building. Okay, so you have a lot of things, but the thing is we don't have infinite time to learn a lot of things, right? So you precisely whatever you saw, each function you'll see throughout the course, and after that also, right, you'll be using it. Okay, so similarly we'll do this for Pandas. Okay, we are trying to do data analytics using Pandas now. Okay, let's see. Okay, so let's see this. Okay, so when you have import Pandas and PD, this is what you are doing to import the library. Okay, after that, there are two popular data structures in Pandas. One is your series, other is your data frame. Okay, one is series, one is data frame. Imagine series as one column. Okay, data frame is collection of series, that means collection of columns. Understood? Data frame is a tabular representation of the data. Series, when you talk about it, is precisely one column.
It has it has multiple rows though, right?
Multiple rows, of course, or one column. Okay, what is the property of one column? It will be homogeneous, right? Whereas a data frame, of course, different column can be of different types, so it is heterogeneous. Fine? Okay. So now we have series is equal to PD series data. This is the data and this is the index number. What is index number of a column?
1.
No. Index number of a column is the information in the left hand side of it. Right. If you see multiple columns, how all the data which corresponds to single index value will be in the same row. Okay, so remember one thing, that series, data frame all have index information, and all the data that belongs to same index are part of same row. Yeah, see that's all the data which has same index, all the columns which have all the values in all the series which have same index are part of same row. I'll show. See here for example. See here for example. Okay, see here for example, we have this series is equal to PD series data 1, 2, 3, 4, and this is the index values. What you're trying to do here is, okay, you just created a series. You can notice one thing, this is the index values, right? If you see, remember Excel sheet, in the left hand side of it, you'll see some numbers there or something over there, right? That is your index values. This is the values corresponding to it. If you want to get index of a series, you'll write series dot index, right? You can press tab to see all the options over there. Dot index, it will give you index values. If you want to get all the values, then you write series 1 dot values.
So here we have given explicitly the indexes from A to E.
Right.
So if we don't give, by default it takes something else like number. Like line number 2 where you have given series data, then 1, 2, 3, 4, and the index is A to E. If you remove that part.
Yeah, you mean the index, this part?
Yes.
Yes, it will by default generate indexes which starts from 0, 1, 2, 3. Okay, so here you can use, it's very similar to a Numpy if you compare. Okay, in Numpy you don't have the provision to provide externally the index values, whereas in series you can pass the index value. Your index value can be your numbers, your string, anything, and for that matter index needn't be unique. Okay.
Like a label.
Huh?
Just like a label.
Label, just like a label, absolutely.
It should not be unique.
It needn't be unique. Okay, needn't be unique means I can have multiple index values same. Okay, I'll show that. Say, how do you access a value? Series name, in a bracket you write index values. Precisely, this is how you access it. And when you don't give any values, see here, you're not passing any index values, right? So what happens to the index values? It automatically gets generated 0, 1, 2, and so on. Right, and what I was talking about series, a key index value not unique. I'll show it in a couple of minutes. Just wait for. Okay, see here. So what do you have here? You have a dictionary here, isn't it? You can convert a dictionary to a series, where the index becomes the key. Isn't it intuitive? Right, the index becomes, see here, ABC was the key here. It became the index, and so on. Right. So what you did here, you converted a dictionary into series.
What does the colon denote? What does the colon denote in that?
Colon.
Be equal to
This is a dictionary. This is a key. This is a value. Python dictionary.
Okay.
Okay. This is key. This is value. This is key. This is value. Fine.
But in dictionary keys are always.
In dictionary keys are always absolutely, but in series keys needn't be, index needn't be unique. I'll show that if that is reading tomorrow. Just wait for a couple of minutes.
Can you convert the series to dictionary?
Yeah, of course. Of course. If you, I mean, you can do everything.
I mean, there is shortcut or
No,
we can do. But,
no, I'll wait. I'll do that.
There is shortcut.
So this is your series, right? For that matter. This is your series, right? Right. If you do series dot to dict.
Oh.
right? 0 is the index value, 1 is the value. 2 is only the index value. Okay, so you can convert, remember a series is column, you can convert a scalar value into a series as well. So what is this? 0 is a scalar value, it's not a list or something like that. And what is the element index? ABC. So what does it create? It creates a column like this, right, where ABC is the index and all the values are initialized to 0, right? What are you trying to do here? You're trying to create one column here, right, with all values same. Okay, so now okay, now let's see, you're trying to access the values here, right? So this is your data, this is your index, right? Okay, if you want to see series 1, okay, now a very important point to note down. When you do this, if you're trying to access with colon C, what will be the result to see the answer? In this case, what will be the output? Colon C. ABC.
The content
C will be included or excluded? Huh?
It should be excluded.
Right, because that is what we have learned so far. Last number is never included, but that is only true for indexes. I really appreciate everybody's honesty here. Okay, despite of seeing the result, everybody stick to what they believed. That's good. So so what what is the gocha here is, when you write this, if you write with, just note down this point, these are like that important points to note. When you do colon C, right, how are you trying to access the data? You're trying to access the data based on index values. You're not accessing data based on index numbers. You're trying to access it based on index values. Whenever you're trying to access information based on values, it is inclusive of the data, of the key. That means in this case, C is inclusive. In the example below it, if you see, I'm trying to access it based on index number, right? I'm trying to access it based on index number. So, okay, I'm trying to access it based on index number.
Implementing 2 index C.
Huh?
Implementing 2 index C.
If you try to colon C, I mean C, right? You'll get. Yeah. If you do, you just access C, you'll get both of them. Okay, I have some examples here. Okay, if you do this colon C, here you'll get ABC. If you give colon 2, it is 0 and 1. 2 is exclusive.
Okay.
Right.
And suppose if we don't give the index name, so by default it will be 0, 1, 2. Correct?
Right.
If we give 2, then it will take it as an index.
It will take it as an index.
Index name or index number?
You haven't given any number anyway. Okay. If you overwrite it, then you will take control. You're not overwriting. I have that example. Okay, see here. That's precisely the example that you're asking me. In this case, you see here, you have index as numbers. Did you notice this? 1 and 2. Index as numbers. Right. Okay, so when you do colon 2, it will include. And what will happen if I give till colon 1? Right? So what is happening? This is overriding the index numbers. Right? This is overriding the index number. Make sense? Okay. So if you are using numeric indexes, you're overriding the index numbers. Here on, you lose the information about the indexes. Similarly, if you do B colon D, D is inclusive, starts with B. Right? Okay, let's create a series. Okay, and do this. Have same index repeated twice. Okay, same index repeated twice, and then try to access series bracket that index number. See the result. Got it, right? And then in the same series, try to use that colon index value. Right? I mean, you first create a series with same index values, try to access it, then try to access it with colon index values. Everybody got access to that? So when you do colon, that thing you're getting all the numbers still there, or you're getting first number? Or you're getting all the C's? I mean all the B's. I mean if you are doing colon B, right? Till the last number, right?
It says cannot get right slash unique level, non-unique level.
नंबर से करने सारे स्ट्रिंग लेके सारे
That's because the 1, 2, 3, 4, 5, 6 is you're getting all the values. This is fine. Cannot get bound of non-unique level. Okay, so what does it mean? For you, it would have worked because no, it would have worked because understood, right? Why it would have worked? You're writing till continuous, right? And if you change it here again, see this. Understood, right? Very important point. Okay, very important point. Okay, if you may want to make a star somewhere and note it down, this extra case. Okay, understood why it is happening? Can you tell me why? See, the idea is internally when it is trying to store it, it will do some level of optimization internally. Okay, and generally if the keys indexes are repeated, you won't make it sparse enough, right? You will try to keep it continuous. Right, you're fine with repeating the index, but it should be continuous. It should be output all together. Right, suppose you have say date-wise transaction, date is your index. Same dates will come together, right? It's not that one will be there at one will be there. Right. This is the assumption. This is how it works. Thank you. Just give me 2 minutes to get some water. Right, clear so far? Okay, that's append part. Append is nothing but if you're trying to combine two series, it will make sure that indexes are continuous, like ABCD is one index and 0, 1, 2, 3 is one index. Just put them together, that's it. That is appending a series to another series. It's not that useful. Now, you see
here the number of rows in the column should be similar when you append. It cannot be. Series always
only one column, right? So when it is data frames, what you're saying is true. Okay, data frame, as we discussed, it is analogous to a spreadsheet. Okay, then it is a collection of CDs, many CDs combined together. Then mutable, that means you can change the contents of it. Okay, heterogeneous, that means different column can be of different types. Fine, right? Okay, let's see this. When you have the series, create a data frame from multiple series. That's what we are trying to do now. We have series 1 and series 2, right? Series 1 and series 2. And these are the index values A, B, C, D, A, C, D, B, E. Right? You see some differences in the index values. And when you try to combine this series to create a data frame, PD data frame, this is the first column, S1 is equal to series 1, this is the first column, S2 is colon series 2 is the second column, right? So remember what I mentioned about combining series to create a data frame. All the values corresponding to same index will be in the same row. Okay, that's what you see here. Okay, this is one series, this is another series. Okay, and A corresponding to A, the value is 100 and 222, same row. Corresponding to B, the value is 200 and 555. See this in the same row. Did you notice this? Okay.
Don't have the value to 0. If don't have index corresponding index number series.
Yeah, it will put NA in here, not a number. Got it, right? Okay, so that's how it will map it. Do you see any discrepancy here? Do you see something which is not expected here? Anything?
It creates an index for E.
That's okay. That's expected. Do you see any discrepancy here?
One was float, rest was changed to float.
Huh?
one of the content is float, all the numbers.
Right, you saw it. Good eyes. So here, you notice one thing. This column was integer. This column was float, but apparently what has happened over here is this has also become float. You know the reason? The reason is because of this NaN. Okay, you want to see that? E, right? Let me get rid of E once. Okay. Make sense? Actually, it is taking some data from earlier, I guess. Yeah. Okay, but essentially you don't see any more dot zeros here. So NaN, because of the NaN, it is imbibing that. Fine.
Python don't know the data type of it, so it's
By default, it is making it float. Okay, similarly, you can see here, this is creating a series over here, and if you, that's pretty much so. If you are, so remember, df is your data frame with 2 columns, isn't it? Right? If you want to access a particular column, you do df double bracket s1. If you want to access it, this is I'm explaining the difference between this. Okay, see this. Can you see this? What is happening? Column data frame dot column name. This is written. This will return your series. Data frame in the double bracket s1. This will return you a. This will return you another series like this. Right.
what is the difference?
Huh?
Second one is showing the series. First one is just like developer.
Right. So here, yeah, this is a data frame. Remember, if you're trying to access single column, right, by default, if you do like this, it will return you a series. If you want to access multiple columns, you will have to give list of column names inside it. Then it will return a sub data frame. Okay, if you want data frame of 1 column out of it, you have to pass it double brackets. If you pass single brackets, you will see you are getting a column series, not a data frame, like this. Okay, so what is the difference between series and data frame? Data frame has a lot of more utilities. So if you want data frame, you better give double brackets like this. Okay, so here, if you see in this case, you have data frame and you have 2 columns over here, right? 2 columns. This is 1 column, this is another column, and you're getting a data frame. That's it. You want to delete a data frame, delete df and the column name. It will delete this particular column from the data frame. Then I think you add a new data frame, you do this. Df, this is a new column name. This is an older column name, and you're adding 100 to that. The important point here is adding a new column based on the previous column is very easy because the index numbers are retained. But if you say you have an existing data frame and you want to add a new column with all values 0 initialized or all value hello like this, what you have to do here is you have to make sure the index information is copied. You have to make sure the index information is copied. Okay, that is why index is equal to df_in. Df is your final data frame, right? Okay, so if you do df index, the index information is retained, and there whatever you write, because it will understand only the index. So that is why it becomes like this. So you have to make sure you're copying the index values, and once you do that, you can do S4 is equal to S4. It's fine. Is it clear?
If we already have an existing series, can we modify the index?
It's mutable. We can modify it. Fine. You can create a data frame from Numpy also. You create a data frame, pass a Numpy array. You can see here 2 cross 4, right? 2 cross 4, and index is equal to a comma b, and columns is uvwx. Okay, so that is what you see. You can create a data frame which looks like this.
Columns are optional, or this is mandatory to do? When we create using Numpy, so columns are optional, or you have to do like column is column optional?
Column, if you don't give, it will take it 0, 1, 2, 3.
But index we have to give. Same thing with the index also, right?
Index, if you index, it will take 0 and 1, right? Fine so far. So we have some HR data, employee data, CSV file. This is how you load CSV file and create a data frame directly. Read CSV. Don't forget, or rather be always wise to put R before it, to treat it as a regular, as an expression, because if there is some escape sequence, it can create problem for you. Okay, so here you're reading the CSV file. Okay, and it creates a data frame for you, HR data. The first thing that you should be doing when you get this data is you want to get some glimpse of the data. So that is why we do HR data.head. It will actually dump the headers of the data.
How many rows? First 5 rows.
First 5 rows you will see. And if you want to see more than that, you can pass here that 10 rows. If you want to see all the data, you use this and dump. But remember, it will be too much of data, so it will be logging your screen like this. Got it, right? I'll get back to the head of the data. Understood? First you should. R is basically, many times when you are dumping the file, it will have slash. If you're copying Windows path, the file name will be slash some directory, slash some directory. If it's slash D, right, it will treat it as that escape sequence and all that. Now you want to see all the column names, right? You do this HR data.columns. It will give you all the column names precisely. If you want to do HR data.info, right? If you do HR data.info, what you will get here is you're getting a brief summary of the data, right? Brief summary of the data, as you can see in this case. Okay, so here you can see these particular columns have all the non-null values are 14,999, right? That is the total amount of data. So there is no null values. What is the data type of first 2 column? Float. What is the data type of last 2 column? String. Object means string. Okay, and then you have these 5 fields, 5 or 6 fields, right? Here it is all integer. Make sense? This is your info. Info gives you a brief understanding of what the data looks like. Okay, then you have the describe. Describe will basically show you information about the numerical columns. Okay, like for example, satisfaction is a numerical column. It will give you count of it. What is the total count of it? 14,999. What is the mean of it? 0.612. Right? What is the standard deviation of the data? What is the minimum data? What is the 25% of the data? What is the 20 other percentage of the data? You see that.
All the numerical columns, it is
right. Okay, so then you have this indexing and selecting. Okay, indexing and selecting. So what is happening over here? You want to get some rows of data. Okay, that is why you are doing HR data 1:4. You are getting row number 1, row number 2, row number 3 with 4 exclusives. Right? So when it comes to accessing rows of data, there are two ways to access it. One is using the lock utility, one is using the iLock utility. Lock and iLock. So the better way to access some rows is this. Okay, because if you're trying to access in the previous technique, right? Suppose you want to access 4th row. Remember, this will not work. Okay, of course you can do this. Slicing will work. Of course, if you do this, it will work. Understood, right? Okay, but this is not the way you access it. Okay, you can actually use lock, access the index by value, right? Where you see the index, these are indexes right here, right? When you write lock 1:4, that means it will. What is the rule? Remember regarding values, accessing by values. Last number is inclusive, right? That is why LC 1 to 4.
So here the index, if you go up, so it doesn't start with 0. Start with 1.
Which one?
The index is 1, 2, 3, 4.
Yeah, the actual index is starting from 1 here. That's how the data is. Starts from 1. You don't have any. It starts from 0, right? Oh, cool. So, but it is not using this 0 is your index by values. This is accessing by values. So when you do 1:4, right? 1, 2, 3, 4, yeah. Got it, right? So when you do 4, unlike earlier, it will give you that particular row, the entire row. Okay, you can see this is the key, this is the value for that row. If you want to access a particular field, got it, right? Okay. Okay, now let me show a bit more when it talks about lock and iLock, right? Let me show a better example. Okay, this is a JSON file. You are loading JSON file like this, read_JSON, right? Read_JSON. So if you try to see the data, you can see here what is the index. Movie names are the index. What is the columns? Direct index. Oh, you are seeing movies, right? Nice. Okay, so if you do this, you'll basically get all the information, and you can see here Chris Duncan AC 2 non-null values, right? 2 non-null values, others an NaN, right? So your info will always show you that brief summary of null, non-null, and all those information. Right now, basically, what I want to is I want to access. This is column, this is index. See, lock I'm doing, right? Lock. Remember, Goodfellas. This is by value, right? Goodfellas to Scarface. So it will be including Scarface and including Goodfellas and the data between it, isn't it? Yes. That's what it is. Okay. Now the other variation of lock is iLock. iLock means by index, right? So when you write 1, 2, 3, will 3 be inclusive or not? Not inclusive, because by index the last thing is not inclusive, right? Okay, so you will see here 1 and 2 only. 3 is not inclusive. Make sense?
If we just put one column, it doesn't show in the tabular format. It shows column.
Because it will be one series of. I mean, you can convert the row into series actually.
Because when we use multiple columns, then only it shows in the tabular.
Yeah. It will give you return a sub data frame to you, right? When you do slicing. Let's see here. You have this movie data.lock. Okay, and you can see here I'm trying to do some filtering sort of thing which I learned in NPware as well, right? See here you're doing movie Samuel Miller greater than 3, right? Here movie data Samuel Miller less than 2, right? So you're trying to lock if okay, it returns you if I simply do it, it returns you a boolean, like so whichever is true will be returned here, right? So these 5 data is true here. Understood, right? Same as we do it in NPware. Remember one point, you lock. So what is lock? Lock by values, and you can see here it is getting indexes by values. It will not work with iLock. Okay, your filtering do not work with iLock. If you want to mark it somewhere, I've written it somewhere as well. Yeah, see, movie data iLock won't work. It will not work with iLock. Okay, so let's see this. So you have this movie data, yeah, lock this thing, and this is a condition. Now you want subset of columns, right? As we have done it earlier, you have to pass it like this, right? Subset of columns. It will give you that particular data only, rather than all the columns.
Why do you use double brackets?
Yeah, because we'll in the double brackets you are passing list of. If you don't give that, right? Yeah, we have to pass. We have to pass all the columns that we are interested in the list format. That is why we do this. Okay, like this. So, and the other API is at you give the row, the index number and the column number, you'll get the value corresponding to it. Make sense? This is the index number, this is the value number. Row comma column, right? Or if you have IAT means index number and column number. Fine? Right? This was about series and data frame accessing and creation, right? Any questions so far? Okay, next topic would be reindexing, selection, and label manipulation. Some part of it we have already explored. Just give me one. Let me know if you have any doubts. I think everybody knows where can they see the contents, isn't it? Okay, just go through this quickly, 5 minutes. If there any doubt, let me know. Right, series and data frame creation and access. Just go scan through it.
We are not saying that Numpy mask file.
Mask true, false.
We are not seeing file in GitHub.
Oh, you're not seeing that file? No, I'll check that. I'll upload it. I think the mask file is now. I'll upload it. Any doubts?
Would I have to raise a pull request to pull this data from?
Just fork it. Create an account, just fork it. Or download it.
We need to upload these files, right, to our Jupyter notebook, and then we can access them.
You can, I mean, of course, you can. I would recommend you to see it and write it again yourself.
No, mainly on data files actually.
Oh, download it. Keep in the same directory
Where the file is.
Or usually I will do data slash. I mean, just make sure that it is in the right relative directory. Inside the same folder, right, where your notebook is there. Try to be there. Try to put it in the same directory or in some relative
data folder, and then here in the name you can see it.
Right. Okay, let's proceed further. Okay, so here it is. We're trying to do the second topic, reindexing, selection, and label manipulation. We have this Titanic data. Very standardized data. Just that initial things we use it. So here you have you can see a lot of information, but you can see there are two index values here, isn't it? Passenger ID also is generally a good index value, and you have default index values here. You would like to make this passenger ID column as index column, isn't it? Then for that, what will you do? PD read CSV data Titanic train CSV, and index column is equal to passenger ID. Right? Index column is equal to passenger ID. That will make this particular column as index column. Right? Okay. And of course, you're trying to see ahead of it. Then few information add suffix. It will add this line underscore column underscore to all the column names. Right? It is right adding this to all the column names underscore call. Okay.
What is the user?
This many times, you know, if you are combining multiple data frame, you would need some identifier, tag identifier. You can use this guy to actually give the column names to that.
Remove the passenger ID column and name the indexes.
No, it just returned it. If you want it to be persisted, then you have to write few more things over here. So you can see here, right? This information.
Temporary just returning the value.
Right. If you want to retain it, either you return the value in the same variable name, right? Or you can do this in place is equal to true. I have to execute from the beginning. In place. I've also got an it does not take in place argument. Yeah. So what you can do here is right. So now onwards, you'll not get that. Clear? Okay. If you want to drop a particular drop column names, drop rows, you can do this 0 and 1. It will drop rows 0, and you can see the data is dropped actually here. Okay. In place, when you write in place is equal to true, you see here it starts with index value starts with 1, right? So because my earlier it was 0, so I had 0 here. So you have to write 1 comma 2, right? If you see now, see it does not start with 1 and 2, it starts with 3. Make sense? Similarly, if you want to drop one column, the fair column, right?
What is the use of that in place equal to?
When you make in place is equal to, remember this, that is why I was trying earlier also. Whenever you want it to modify the data frame, otherwise it returns a new value. Remember this. If you don't write in place, it will return a new value. If you put in place, it means it will modify the data structure on which the operation is carried out. In place is equal to, remember this. In place is equal to true. What it will do, it will actually modify this particular data structure and it will drop two rows.
These data files are already present in GitHub.
Yeah. Maybe some folder things, but it's already there. Understood, right? Here, what happened? Let's proceed further. If you want to drop a particular, remember the previous way we do del and that column name, right? This is another way you can drop it. Drop fair access. What is access 1? So what does it mean? It will drop all the rows of fair column. That is the entire fair column will be gone. Okay. When you write this drop fair, what it will do? It will drop the fair column. Access 1 means all the rows of that fair column.
If you don't write,
no, then it will try to delete. It won't work then. If you don't write x is equal to 1, right? By default, it is x is 0. X
deletes all the rows where the value of fair is existing.
No, it will delete all the rows of fair column.
Basically, to delete the
fair column, yeah. But how to read and understand it? X is 1 means this, right? So you have to delete all. I mean, this is how you should train your mind to read this actually. Okay, so what you're doing here, you're deleting all the rows of fair column. That's it.
It technically deleted the fair column.
Yes. But the way you read it, the way, because this is how internally it is working. It is deleting all the rows of fair column. Then it is deleted.
But in the above case, you just drop 1, 2. Those are rows. Okay.
That is rows. Yeah, yeah.
And no need to use index.
If you, yeah. So if you do this fair, it has already deleted.
On the same data set, return.
Fair, right? Let's see. Here it's here, right?
And
because we didn't do that in place is equal to true. Fine, right? If you do this in place is equal to true, right? Whichever suppose in place is equal to true, right? No more fair. Okay, so now I'll come to the duplicates part. Okay. I think yeah, this is one more time I will discuss duplicates anyway. So you see these duplicates. See this, we have this data frame. Right, we have this data frame which consists of 2 columns, A and B. Right? Okay, so here you have df drop duplicates. It's precisely dropping that. Sorry. Okay, so here you have data frame df. You have this many rows here. You do df dot drop duplicates. What happens over here? Okay, it will drop the duplicates. Like this particular column row is repeated twice, right? So it will delete that, right? So you can see the second row is no more here. The first row is only retained. Then you, if you want to see which are the, even without duplicating, if you want to see, okay, if you see this drop duplicated, so here, okay, here what it will return, it will return all the rows which is duplicated. Got it, right? Duplicated. Drop duplicate will drop it, but before dropping it, you want to see whether these contents are duplicated or not. You can use this df duplicated.
It will return true only if the entire row is duplicated.
Yes. Okay. Now, of course, as you rightly mentioned, entire row. If you really don't want to care about entire row, but only selected columns, you can pass the selected columns like this here. Right? You are bothered about only column A and B. As long as this information are duplicated, you will start doing dropping and all that. And if you want to see which column is duplicated, you just, anyway, it will pass Boolean array. And what you have seen earlier, if you pass Boolean array to the data frame, you will get that particular contents here like this.
Here we are printing data frame where column A and B are duplicate.
Right.
But thing is like technically like column 1 and column 2 both have same value. But when we look for the duplicate, it just returns the 2 for the second. Right, but you need to know what all columns are.
For that, you can get that particular value and then see where and all this appears actually. Okay, what you're trying to find where and all it is duplicated, right? So you can try to find this value in the entire data frame and see how it matches. But more or less, you will basically do this stuff. See, again, drop duplicates. You can pass subset of information, right? A and B. So this data, wherever A and B is common, it will duplicate, and what it will do, it will keep the last one. You can see here 0 element is dropped, right? And the 111 is retained, right? Here keep last. If you do keep first, then the first one is retained. This should again control that level of information. Subset, keep. Then basically filters are there. Filter in this data frame df, you want to select the columns, right? A and C, that's what you're showing here. Column number A and C will be returned back.
But we can do the other way also. Here we are just looking for the columns A and B, but A and C, we can do the same thing in the other block.
Right. Okay, so this is the entire data frame, right? A, B, and C. Now let's see further. We had the Titanic data, right?
Filters are used only for that. Filters are used only for that.
No, this is like filtering columns actually. We'll see towards the end more usage of filters. You can pass a pattern also. Do you want the column which shows this pattern? Regular expression, right? We can we can do those things. Which starts with this, which ends with this. We can do that sort of thing. I'll show that. Okay. See here, you have the data frame which looks like this now, right? And you want to see this. This is pretty interesting stuff. You want to make the name column, this name column, as index of the data frame. So what do you do? Data frame dot set index name and in place is equal to true. Right. So what are you trying to do here? You are trying to make the name column as index. After that, your data becomes like this. If you execute this, right, you can see name becomes index, right?
And where is that index column?
What was the index column? Passenger ID, right? Yeah. But if you what was my index ID? Passenger ID, huh?
Passenger ID.
Okay, now
for interchange.
interchange, for example, take the passenger ID somewhere down the line.
So what do you do? Unset index is unset. Okay, set index this, passenger ID is gone. You again do reverse.
Okay.
Insert it and insert it.
Yeah. So for example, just show the data. So now you have names as index, right? The important thing here is this: if you do filter like MRS dot, it will show you all the rows. There is a beautiful part here. Filters always works on indexes and columns, right? Filters always works on that. So if you do like MRS, it will actually find all the rows, all the indexes whose value contain MRS, right? So I mean, you can do other ways also, but the thing is, if you make one column but index, and if you want to do a lot of things with a column, you want to make this an index, you can actually avoid writing a lot of code. Got it, right? Okay, so many times
We have given accessible filter, so it's
right. Okay, if you see, if you do this, passenger ID is gone, right? That is why it is like this. Okay, so later on we learn about group by. I think everybody is aware of databases and all that, right? Okay, we learn about group by. So that is another topic. Okay, so few small things I'll discuss about merge, join, and concatenate. Okay, and group by and all I'll be discussing over here. Okay, in details. Makes sense, right? Whatever you have seen so far. Okay. Okay, so there are a few utilities. One is you see this data frame here. Okay, and what are you doing here? You do df add 5. What will you do? It will add 5 to all elements over here, right? Okay, this is how it does a lot of this operation. But when you do df add df, what does it mean? It will add the same df to this df, element by element operation, as we have seen in the Numpy. Okay, let's see some concatenation. Remember, concatenation is not the best way to do merge data frame, but definitely the starting point of doing that. Okay, concatenation is a little slower compared to your merge. Okay, and merge is the other API. So let's see how concatenation works. So you have two data frames. This is one data frame. This is another data frame in this case, right? You have two data frame, and apparently 3 data frame, right? If you are keeping all this data frame in a frame, right, frames list, keeping all, then you do pd concat frames, right? What will it do? It is, by default it will try to, see whatever data comes under same index, same column names, right? And it is, you can see, by default it is doing vertical concatenation, putting one top of another. Okay.
What does the frames command do?
No, it's the list of all this data frame. Right, list of all the data frames. So if you do this, right, since the column name is same, it is putting in the same row. But remember, this is same data frame has, same index value repeated here because it is in concatenation. This is wrong indexing right here. You want to restore the right indexing. What you can do is ignore index is equal to true, right? It will restore the indexing information here. right? Concat. You're trying to concatenate data frames, right? Concat frames and keys. Many times you want to know, retain the information what is what. So you can see this is hierarchical indexing here. This is one level of indexing, year, month information, right? Hierarchical indexing. You're combining data frames together and passing it these keys over here, hierarchical indexing.
Is there any multiple levels?
Yes. Once you create this, you can access it by first level, second level, third level, and
Like you always do keys, like here X and then you can you do multiple levels?
Not in this case. Okay, multiple levels with one more level you want to add.
Yeah, one more keys or keys.
You might have to, what you would do is you have this data, you have to combine with some other data and add that keys. You have to have 3 levels of information, right? So that is how I will do it. Okay, you have this data, you combine this data with another data, then pass here Z and U. Got it, right? Okay, this is one data frame. Create another data frame like this and merge it by passing that information. Right? Similar to earlier, we do data frame dot lock. This is the first level of indexing. This is the second level of indexing. Year, month. This is first level. This is Y here, right? Y and this is 5. You are getting this row, isn't it? Is it clear?
Okay, if we want column B value for that.
See.
No.
Let me do other thing also. Understood? So now if you have to access this, you'll write, suppose you have to access this line, UX2, right? Okay, that's what lock UX2 and all that you write here. Lock, if you do this, it will give range from this to this, right? Pretty much, right? This is accessing here.
One particular value.
This. Just keep that.
Comma.
Yeah, comma also.
Column name.
Right, you are getting this. So Y2, suppose you are accessing Y. So this case, right? Y5.
Yeah. Okay. Can we write
okay, so here
because we already gave one comma.
Right. Okay, so when you are accessing, see, once you get that row, right, you can access one. This is a series, right? Right, this is a series. Once you have the series, you have to access something, you access it by index. Okay, but remember few things, this last few things. Merge will do. Yeah. So when you do this, when you're trying to do a concat and you're passing here the access information, access one means Horizontal, right? You're adding df1 and df4 horizontally. That means all the data which is same index will be in the same row. Okay, but it will create different columns here, right? df1, df4, you can see, right? What is df4 is this, right? 2 3 6 7, right? 2 3 6 7, this is your df4, right? You can see the values here, otherwise it is all nan. Similarly this value here, otherwise all nan. Make sense, right? On cat. Okay, now of course you have done this is very similar to your outer join, isn't it? You're just indeed, everybody have some database background? Huh? Okay, not really. So folks who are not really, I would encourage you to over next week take up this W3 school and learn a little bit of SQL, because it will pay big time, because a lot of API after this concat was a starting, after this the merge, a lot of group by will be very useful if you have some SQL query language understanding. Okay, because this is predominantly data processing APIs, right? It has to inherit something from SQL. If you are aware of database, then you'll find a lot of things very similar. Okay, so okay, I'll stop it here. Okay, we'll discuss append and merge, but remember now group by, join, all these things will come, and it has a lot of database similarity. Okay, if you don't have those things in your memory, maybe you can brush those concepts. Okay, so that you can find the rest of the journey easy. Okay, I'll stop it here. Any questions, folks online? Manjit, Tharun, Vinay, Yesh. Okay, let's catch up over next weekend. Please go through all the stuffs, practice the code. Assignment is over here. Wiki. Okay, Numpy problems. Pandas assignments. Okay, Numpy's problems should start. After that, there is. They click on this assignment. I think this is not the stuff. But anyway, the class do data science assignments. This is another place where you can Pandas and Numpy assignments.
Those are the two different assignments.
Right. Okay.